So let's recall that linear relationships have constant slopes or rates of change. So remember, that's the change in your y value over the change in your x value, output over input. So to see if a relationship is in fact linear, we have to check both of those. So if we're given a table, like in example 4 and 5, we first check, are the inputs uniform? In other words, are they of equal intervals? 3, 6, 9, 2, 4, 6, the same spacing. The second thing that we check are what they call the first differences constant. In other words, if you were to subtract consecutive output values, are they the same? So let's take a look at example 4. So these are examples of checking for exact or approximate linear relationships. Well, I know when we go from 1 to 5, that's a difference of 4. 5 to 9, you added 4. 9 to 13 is 4. 13 to 17 is 4. 17 to 21 is 4. So these are uniform inputs. So now that those are uniform, we can check to see if the first differences, basically the differences of consecutive output values, are the same. So here we have 88 minus 98 gives us a negative 10. Between these two, 78 minus 88 is a negative 10. So between these two would also give us a negative 10. 58 minus 68, negative 10. 48 minus 58, negative 10. So we're kind of, consecutive numbers. We are getting that same difference. So no matter which 2 points we pick, we are going to get the same change in the y value over the same change in the x value. So that means that we have exact linear relationships. And again, that means that our first differences are constant. In other words, they're the same. So now let's check out number 5. From 2 to 4, we're adding a 2. 4 to 6 is 2. 6 to 8 is 2. 8 to 10 is 2. 10 to 12 is 2. So again, we have uniform inputs. But now let's check out the differences. So 40 minus 35 is 5. 46 minus 40 is 6. So right away, we know that it's not going to be exactly linear because those differences are not the same. But now we have to see, can we even use approximately linear? Because those differences still need to be close. So then we have 50 minus 46, which is 4. 54 minus 50, which is 4. And 59 minus 54, which is 5. All of those numbers are relatively close together. We didn't have one difference of 5 and another difference of 20 and one of 15. They weren't all over the place. We can say that the first differences are close or similar so that this is an approximate linear relationship.